Okay, so yesterday, boys and girls, we worked really hard to make these fraction strips, right?
Yes.
So let's all take a look there. What are some things we remember noticing as we were making these? Dan.
The two big ones equals a whole.
Equals a whole. That was a really good observation. Do you have one you want to share, Christian?
So 6 holes. No. 6 equals this. 1. No. 2.
Let's look at this. What are some observations we made here?
1 hole is.
This is one hole.
3. No. 5 makes 2. 2 hole.
2 halves make a whole, and then 5/5 make a whole, right?
Yeah.
And we also, I remember us talking about, we talked about 1/2 is bigger than 1/3. Do you remember talking about that? Here, I can hold this up. Do you have one you want to share?
1/2 is also equal 1/4 of 2 of 2/4. So 1/2 is equal to 2/4. That is beautiful, Ariana. So do you remember what we called that when we said 1/2 is about the same size as 2/4? Yeah. Yes.
That is called an equivalent fraction. That's a pretty big word. Equivalent fraction. So equivalent. What are some other math words we hear in the word equivalent? Do we hear any other math words? Equal. It sounds a lot like equal, right? And that's exactly what it means. Equivalent means equal to. So if we're putting it in a sentence, we can say that 1/2 is equal to 2/4, right? So I thought we could pull it into another perspective here for us, and we could look at pizzas. So let's put our imaginary brains on, and we're going to pretend that these are
But I'm
pizzas.
using caps.
Okay? So let's pretend that you are coming home from school, and you are just so hungry for pizza. Okay, it can be pie. It can be pie, I like that. So you are just so hungry. So your mom or dad or grandma, brother, sister, whoever helps you make dinner at night is there, and they make you a pizza, and they decide to cut that pizza into 2 equal pieces. Right? 1 piece, 2 pieces. So we have 2 pieces to our whole, right?
That's the denominator.
That is the denominator. Awesome math language.
Also, so then you would have 1 big piece for snack and then the other one for dinner.
Exactly. You could have 1 now and 1 later. So let's pretend we're eating this piece, right?
Yum, yum, yum.
Yum, 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 yum. That piece is gone. So we eat
1.
1
Whole. 1/2. The denominator.
of the 2. So 1 is the numerator. And this one down here is the denominator. The denominator represents the whole,
Like all the pieces.
all of the pieces, and the numerator represents the
one that's left.
the part, right? And the whole. So, let's pretend then, instead of cutting the pizza in half, whoever's helping you cut this pizza, cuts the pizza into 4 equal pieces. So we have 1, 2, 3, 4 equal pieces.
So,
Okay? Now, you still want to eat half of that pizza. So by showing your hands, how many pieces of the 4 would we need to eat to still eat half of it? Dan, your hand was up. 2! We need to eat 2 of those pieces, right? So let's pretend we eat 2 of those pieces.
it gets smaller.
And you can see that these are the same. Yeah?
And then in the bottom.
So here, the only difference between these two is in this part we had 2 parts, and in this pizza we had 4 equal parts, right? So we used 2 of the 4, and they're the same.
I know it.
So just for fun, let's pretend that we have one more pizza, and we're gonna eat, or we're gonna cut that pizza into 8 equal parts. So we have 8. So how many pieces of those 8 do we need to eat half? 4. That is awesome. So let's just shade in our 4 pieces here. So we can see by looking at this that all of these fractions, even though their numbers change, they all represent the same amount on each pizza, right? Another word for that amount is quantity. So equivalent fractions represent the same quantity, same amount. Dan, do you have a question?
So Miss Jessie, what we're doing though is that like every time that we're doing one, it repeats itself. So like we have 4, and then it repeats itself to 8.
So you noticed a pattern there, which is incredible. It's incredible math skills. He noticed that we're going from 2 to 4, we're doubling it, and then we're going from 4 to 8, and we're doubling it again. So not all equivalent fractions are going to follow this pattern. What happens is when we multiply the numerator and the denominator, so the numerator is that top number, right, and the denominator is that bottom number, when we multiply them by the same number, we're going to get the same quantity, that same amount, even though the numbers change. So let's look here. We multiplied this 2 by how many, Dan?
2, 4.
Yes. How much did we multiply? 2 times
2 times 4.
2
2 times 2.
2 times 2 is 4, right? So then we have to multiply our numerator by the same number. Can you see this, girls? We have to multiply our numerator by the same number to get 2, right?
And 2 times 2 is 4.
And then we can do the same thing over here, right? We multiply that 4 by 2 to get 8. And then we multiply this by 2
times 2 equals
to get 4. So that's another way that we can just check to see if the fractions are equivalent or not equivalent. I thought then, after this, we could play a little game. Do you guys want to play a little fraction game?
Yeah.
Okay, so this is called Fraction Buddies. So what we're going to do is I'm going to mix up these cards, and you guys are going to take a turn drawing a card from this. You're not going to look at it until everyone has a card, and then when I say go, you're going to look at the fraction on your card, and you're going to try and find your buddy that has the equivalent fraction. Are there any questions about those directions? No. Okay, let's go.